In the summer of 1969, humanity achieved one of its greatest milestones. For the first time in history, humans set foot on another world and looked back at Earth from the surface of the moon. The Apollo missions were not only a technological triumph, but also a moment that reshaped how people saw humanity's place in the universe. Millions of people around the world watched the historic landing live on television. The images were grainy, the audio sometimes unclear, yet the emotional impact was undeniable. It felt as if the impossible had suddenly become real. During the Apollo missions, astronauts captured thousands of photographs. These images documented scientific experiments, the lunar landscape, and the daily work of exploration. Each photo served as both scientific evidence and a visual record of one of humanity's boldest journeys. Most of these photographs were accepted without question. They showed dusty terrain, long shadows, and astronauts moving carefully in low gravity. But years later, one particular image began attracting unusual attention. At first glance, the photograph seemed ordinary. An astronaut stood on the lunar surface, while equipment and shadows stretched across the ground. Yet some viewers felt that something about the lighting looked strange. The shadows in the image appeared to fall at slightly different angles. For some observers, this suggested the presence of multiple light sources. They began asking whether such lighting could really come from the sun alone. As time passed, the photograph was reproduced in books, documentaries, and later on websites and forums. Skeptics pointed to it as evidence that the moon landing might have been staged. What started as a visual curiosity slowly became part of a much larger controversy. To understand the debate, it is important to understand how lighting works on the moon. Unlike Earth, the moon has no atmosphere to scatter sunlight. This means shadows are darker, sharper, and more dramatic than what we normally see. On Earth, sunlight is softened by air, dust, and moisture. Light reflects in all directions, filling in shadows and reducing contrast. The moon, however, receives direct and unfiltered sunlight. This harsh lighting environment can make scenes appear unnatural to human eyes. Objects may look overly bright, while nearby areas fall into deep darkness. The contrast can create visual effects that seem artificial. Another important factor is the shape of the lunar surface. The moon is not flat, even though photographs sometimes make it appear that way. Small slopes, ridges, and uneven ground can change how shadows fall. If two objects stand on slightly different angles, their shadows may not appear parallel. This effect can make it look as if multiple light sources are present. In reality, the sun remains the only source of direct light. Perspective also plays a major role in how we interpret photographs. When a camera captures a wide area, parallel lines may appear to diverge. This is the same visual illusion that makes railroad tracks seem to meet in the distance. The position of the camera can exaggerate these effects. Apollo astronauts often took photos from chest level while wearing bulky suits. The resulting angle sometimes distorted depth and alignment. The cameras themselves were highly specialized. NASA used modified Hasselblad cameras designed to function in extreme temperatures and vacuum conditions. These cameras captured high-resolution images with strong contrast. Film exposure was carefully controlled for bright lunar conditions. Since the surface reflected intense sunlight, settings were optimized to prevent overexposure. This sometimes caused shadowed areas to appear darker than expected. However, the moon's surface also reflects light. Lunar soil known as regolith, has reflective properties that bounce sunlight in many directions. This reflected light can softly illuminate objects that are not in direct sunlight. This effect is called surface reflection, or albedo. It explains why astronauts and equipment are sometimes visible, even when standing in shadow. To viewers unfamiliar with this phenomenon, the lighting may appear unnatural. The historical context of the time also influenced public perception. The Apollo missions took place during the Cold War, when political tension between superpowers was intense. The space race was as much about national pride as scientific progress. Because of this competition, some people later wondered whether success had been exaggerated or staged. The idea that the achievement might have been too perfect began to circulate. Suspicion grew, alongside fascination. Media coverage in later decades played a major role in spreading these doubts. Sensational claims often received more attention than detailed scientific explanations. Television specials and early internet forums amplified the mystery. As the internet became widely available, conspiracy theories reached global audiences. Images could be shared instantly and discussed endlessly. The Apollo photograph became one of the most frequently cited examples. Scientists and experts responded by analyzing the image in detail. Photogrammetry, lighting models, and terrain analysis were used to recreate the scene. Their findings consistently supported the authenticity of the photograph. Professional photographers also weighed in on the discussion. They explained how perspective, terrain, and exposure settings could produce the observed shadow patterns. To trained eyes, the image showed nothing unusual. Despite these explanations, doubts continued among some groups. Once a visual impression creates suspicion, it can be difficult to change minds. Human perception often relies more on intuition than technical detail. Psychologists note that people tend to trust what looks familiar. When an environment behaves differently from everyday experience, it can feel wrong. The moon's extreme conditions challenge our expectations of light and shadow. Historical records show that early reactions to the photograph were mostly technical, not conspiratorial. Engineers and scientists discussed lighting conditions as a matter of curiosity. The controversy grew much later. Over time, the image became less about photography and more about belief. It was used as a symbol within a larger narrative, questioning the moon landings. Visual anomalies became evidence for broader claims. This case highlights the power of images in shaping public opinion. A single photograph, when misunderstood, can influence perception for generations. Visual information feels immediate and convincing, even when misinterpreted. It also shows the importance of scientific literacy. Understanding physics, optics, and environmental conditions helps explain what might otherwise seem mysterious. Context transforms confusion into clarity. Today, decades after the Apollo missions, the photograph continues to appear in discussions and videos. Each new generation encounters the same questions and the same explanations. The debate reflects not only science, but also trust, curiosity, and skepticism. In the end, the Apollo photograph is less a mystery and more a lesson. It reminds us that unfamiliar environments can produce surprising visual effects. Most importantly, it shows how easily perception can shape belief long after the moment has passed.